Going to be reviewing greatest common factor and simplifying fractions. So hopefully this is something that you've seen before, especially in middle school. But it's always good to do a refresher before we go into the next unit, which is going to be polynomials. So what is a factor? A factor is a number that divides evenly into another number. So how do we find the greatest common factor between two numbers? So I'm going to give you two methods. Method one is a factor list. So you're going to list all the factors of a number. And then you're going to pair the factors and find the greatest common factor, the GCF. So let's do that for numbers 1 and 2. So for number 1, we have 36 and 48. We want to find the greatest common factor for those two numbers. So we need to list all of the factors for each of those numbers. So for 36, what numbers can we multiply together to get 36? You could multiply 1 and 36. That would equal 36. You could multiply 2 and 18. 3 and 12, 4 and 9, and then 6 and 6. Oops, that's a 9. So how do I know those numbers? Well, I just know them off the top of my head because I've been doing this a long time. If you're not sure, I would use your calculator and just start dividing. So 48 divided by 1 is 48. So you could list 1 and 48 as your first pair. What's 48 divided by 2? It's 24. So then you would write 2 and 24. What's 48 divided by 3? That's 3 and 16. So you can use your calculator to find these pairs. So then we would have 4 and 12. You would try to divide 48 by 5, but you get a decimal. So that's 5 is not a factor. It has to divide evenly. And then 48 divided by 6 is 8. So you can have 6 times 8. And the only number you need to check now is 7, because once you have these two numbers and the only number left in between them is 7, 48 divided by 7 gives you a decimal, so 7 is not a factor, and you know you're done. So let's look at what is the largest number that they have in common. And that would be 12. So the GCF for 36 and 48 is 12. Let's look at number 2 using the same method. 54 and 45. So I'm going to list the pairs of factors that I can multiply to get 54. 1 and 54. 54 divided by 2 is 27. 54 divided by 3 is 18. 54 divided by 4 gives you a decimal, so we're not going to list 4. Same thing for 5. 54 divided by 6 is 9. And then the only two numbers left in between 6 and 9 are 7 and 8. So you can divide 54 by 7 and 54 by 8. Those would both give you decimals, so we are done with 54. Now we would list all of the factors for 45. 1 and 45. 2 is not a factor because it gives us a decimal. 3 and 15. 4 is not a factor. And 5 and 9. And then 6, 7, and 8 are the numbers left in between 5 and 9. All of those will give you a decimal, so they are not factors of 45. The largest number that these two numbers have in common is 9. So the GCF for 54 and 45 is 9. Now let's use method 2, which is prime factorization, or I like to call these factor trees. So you're going to select a factor pair for the number, pick a set of factor pairs for each of those numbers, and then you're going to repeat until it's a prime number. So remember, prime numbers, the only factors they have are 1 and itself. So they don't have any other factors. You're going to list all those prime factors and multiply the common factors. So this will make more sense as we do this. So for numbers 3 and 4, I'm going to use prime factorization. So in prime factorization, you can start with any pair. You don't have to start with 1 and work your way up. You can do any one that you can think of off the top of your head. So for 36, I think of 6 times 6. I'll make a little tree. And then what can I multiply together to get 6? Well, I can multiply 2 times 3 to get 6. And then I would have to do the same thing for this 6. Now we have 2, 3, 2, 3. And 2 and 3 are both prime numbers because you can't divide either of those numbers by anything except 1 and itself. So these are all my prime numbers for 36. Now let's do 54. So 54, you could multiply 6 times 9. And then for 6, you would multiply 2 times 3. For 9, you would multiply 3 times 3. So now again, I have 2's and 3's. These are all prime numbers. So you can see that, oops. We have 2, 3, 2, 3 for 36 and 2, 3, 3, 3 for 54. So let's list those out. For 36, we have 2, 2, 3, 3. And for 54, I have 2, 3, 3, 3. So we need to find what they have in common. They have a 2, and they have a 3 and another 3. The 2 and the 3 that are left over, we're not going to use those. So if they have a 2 and 2 3's in common, we would multiply all of those numbers together. 2 times 3 times 3, which is 18. So the GCF for 36 and 54 is 18. Let's do the same thing for number 4. We have 80 and 96. So I'm going to make my factor tree for each of these numbers. So for 80, what can I multiply to get 80? I can multiply 8 times 10. For 8, I can multiply 2 times 4. 2 is a prime number, so I'm going to stop there. For 4, I could multiply 2 times 2, and I have prime numbers again, so I'm going to stop there. For 10, I have 2 times 5. 2 is a prime number, and 5 is a prime number. So I'm done. I'm at prime numbers at the end of every branch. So now I'll move over to 96. You can start with any pair. I'm going to start with 3 times 32. 3 is a prime number. For 32, 4 and 8. For 4, I have 2 and 2. Those are prime numbers. And for 8, 2 times 4, there's another prime number, and 2 times 2. So now I'm going to make my list. For 80, we have 2, 2, 2, 2, 5. Oops, that should say 80. And then 96, we have 2, 2, 2, 2, 2, 3. So what do they have in common? They have 1, 2, 3, 4 2's. So multiply 2 times 2 times 2 times 2. That equals 16. So my GCF for 80 and 96 is 16. So now that we know how to find a greatest common factor for two numbers, we're going to use that to simplify fractions. So find the greatest common factor of the numerator and denominator. The numerator is the top number and the denominator is the bottom number. And then you're going to divide both of those numbers by the GCF. So let's find the greatest common factor for 5 and 30. So I'm going to do the factor list on this one. So for 5, because 5 is a prime number, I can only multiply 1 and 5. For 30, I can do 1 and 30, 2 and 15, 3 and 10. 4 doesn't divide evenly into 30, but 5 does. So 5 and 6, and there's no numbers between 5 and 6, so I'm done. So the largest number that they have in common is 5. So 5 is my GCF, and I'm going to divide the numerator and the denominator by 5. To simplify this, so 5 divided by 5 is 1, and 30 divided by 5 is 6. So the simplified fraction is 1/6. Number 6, we have 20 over 290. So the factors of 20 are 1 and 20, 2 and 10, 3 is not a factor, 4 and 5. For 290, don't get overwhelmed by the high number. All you're doing is dividing numbers in order until you can't find any more factors. So 1 times 290. 290 divided by 2 is 145. 290 divided by 3 is a decimal. 290 divided by 4 is a decimal. 290 divided by 5 is 58. 290 divided by 6 is a decimal. 290 divided by 7 is a decimal. 8 and 9 also give you decimals. And then 290 divided by 10 is 29. Now technically you should try 11 through 28, but I'm going to stop you there and let you know there are no other factors. So the highest number they have in common is 10. So that's my GCF. So I'm going to divide the numerator by 10 and the denominator by 10, which gives me a simplified fraction of 2 over 29. Okay, number 7. We have 44 over 104. So 44, the lists are 1 and 44, 2 and 22. 44 divided by 3 is a decimal. 44 divided by 4 is 11. 5, 6, 7, 8, 9, and 10 are not factors. So for 104, we have 1 and 104, 2 and 52, 3 is not a factor, 4 and 26, 5, 6, and 7 are not factors, 8 and 13, and then 9, 10, 11, 12 are not factors. So when you're first doing this, this can be a little bit time consuming. It really doesn't take a whole lot of time to put those numbers in and divide. But as you start doing this more, you will be able to kind of have it memorized and see what the common factors are between two numbers. So the greatest common factor in this list is 4. So we'll divide the top number by 4 and the bottom number by 4, which gives us 11 over 26. Number 8. let's use prime factorization or the factor trees for this one. So 56, I have 7 times 8. 7 is a prime number. There's nothing I can divide by except 1 and 7. Then I have 2 times 4. 2 is prime. And 2 times 2. 136. Let's see. I can do 8 and 17. 17 is a prime number. 2 times 4. 2 is prime. And 2 times 2. Now I'll make my list. So for 56, I have 2, 2, 2, and 7. And for 136, I have 2, 2, 2, and 17. So they have in common 3 2s. So 2 times 2 times 2 is 8. That's my GCF. So I will divide the numerator and the denominator by 8, which gives me 7 over 17. Okay, now I have a negative number. That doesn't change anything. So let's go ahead and find the common factors for 56 and 126. Actually, we'll do the factor trees. Okay, so 7 times 8. This is the same as the one in number 8. We can just copy that, actually. 2 times 4. And then 2 times 2. For 126, we have 6 and 21. And then 2 times 3. And 3 times 7. Now I have 2, 2, 2, and 7. Oops, sorry about that. I meant to write the number, 56. And then for 126, we have 2, 3, 3, and 7. They have in common a 2 and a 7. So 2 times 7 is 14. That's what I'm going to divide by. So I'm going to take this negative number and put it with the top number. It doesn't really matter. One of them is going to be negative, but that just means your simplified fraction will still be negative. So negative 56 divided by 14 is negative 4, and 126 divided by 14 is 9. So the simplified fraction is negative 4 over 9. So in today's assignment, you will be finding the greatest common factor and simplifying fractions.